This is an example of using Molview to do the virtual 3D structure of the ultimate example that I showed you in my PowerPoint. Let me just flash you the Lewis structure that we worked out. Here it is right here. That's the Lewis structure. You notice that in my Lewis structure I've got a triple bond between carbon 1 and 2. I've got a carbon double bond oxygen on carbon 3. I've got a nitrogen that has a lone pair and connected to 2 carbons. Towards the end I have a nitrogen with a lone pair and connected to 3 atoms, and then finally I have an oxygen with 2 lone pairs. So that's the example that I am going to create in Molview so that we can look at the virtual 3D structure of this particular compound. First thing that we're going to do is just put the atomic sequence without the hydrogen. So according to my structure, my Lewis structure, I had a carbon. So I'm just going to click on this carbon and put a carbon right here. Next to that was another carbon. Next to that was a third carbon. I'm just going to go in the linear fashion, and then I'll add the branching atoms later. We have a nitrogen here, so I need to change that. The 4th atom is a nitrogen, and then the 5th atom is a carbon from the left, and then another carbon followed by a nitrogen, and then finally an oxygen. The hydrogens are not added because the program is intelligent enough to add the hydrogens based on the fact that carbon always has 4 bonds and it has to obey the octet rule. So the next thing I'm going to do is I'm going to put the bonds in. I know that, in fact, what I'm going to do is I'm just going to connect all these atoms, and then I'll worry about the multiple bonds later. Okay, and then I also forgot the other oxygen that is connected to this 3rd carbon. So I'm just going to put oxygen here, and that is connected by a double bond. And then the 1st and 2nd carbon is connected by a triple bond. So let me make sure that I have that tool. And then the nitrogen and the 4th carbon is connected by a double bond. And I think that's about it. Those are the only multiple bonds in my structure. You can actually use this tool here where it says CH to show the hydrogens in the structure. Okay, but you really need to clean it up in order to make sure that the structure is structurally sound. So that's what I'm going to do. And here you can see that they've added hydrogen on the oxygen, hydrogen on this nitrogen, just to complete its valency. Recall that nitrogen generally has a lone pair. The other thing I want to do is do this so that you guys can see that you could hide the carbon and the hydrogen or display it. Now, all I've got to do now is render this structure to a 2-dimensional format. I'm going to clean it up one more time, and then I will go ahead and convert it. So here it is. This is the structure right here. You can see that, let me try and rotate it in such a way that you can see the different geometries around each atom. Here it is. The 1st and 2nd carbon is in a linear format. The 3rd carbon right here is in a trigonal planar format. That's this carbon right here. This nitrogen is bent. You can see that. It's bent because there's a lone pair on this nitrogen that you don't see. This carbon next to that nitrogen is a trigonal planar. That's this carbon right here. And then the 1, 2, 3, 4, 5, 6 atom from the left, or the 5th carbon, you can see that that's a tetrahedral geometry. The nitrogen after that is a pyramid, and then finally the oxygen at the end is bent. So just to give you a glance of the different ways of viewing this, I'm rotating it, but I'm also going to show you the stick model. And here you can definitely see the geometry around each atom. Linear here, it's going to be trigonal on this particular carbon double bond oxygen. It's bent around this nitrogen. It's trigonal around this carbon right here. That's this carbon. It's tetrahedral on the 5th carbon right here. It's a pyramid on this nitrogen, and then it's bent around that oxygen. Let me show you another representation. That's the van der Waals radius. And here you can see the volume of these atoms right here. Let's do the wireframe. And the line. Change the background just so that you can see the contrast. And based on our calculation, as you saw in the PowerPoint, we have pretty much the geometry around each particular atom. I'm going to go ahead and go back on the ball and stick, and then I'm going to convert it to a white background so that I can do a copy and print of this structure. And that's it. That's how easy it is to use this particular program. Thank you for watching.